Chapter 3 Refraction Part 1 Snell's Law. Not long ago, you have learned the laws of reflection. It was simple. The angle of reflection is always equal to the angle of incidence. This time, you will investigate the refraction of light, that is, the change in direction of light when it travels across different media. For example, when a light ray travels from air to glass, as shown here, the light ray bends. It changes in direction. In a direction closer to the normal, we say that it bends towards the normal. 3.1 Refraction across an interface. When there are two media, for example, air and glass, the line between them is called interface. When a light ray travels across an interface, it changes in direction. We call it refraction. The angle of refraction and the angle of incidence are related by the Snell's law, as given here. The ratio of the sine value of the angle in air to that of the angle in x is called the refractive index of x. So, how can we verify Snell's law? That is, to show that Snell's law is correct, we have to do an experiment. 3.2 Refractive index Snell's law experiment. Similar to the last experiment on reflection, you will also be given a worksheet in the next lesson. The experiment is straightforward, just like last time. You will be given a semicircular block made of perspex, which is a kind of hard transparent plastic, the same material as your plastic ruler. Then direct a light ray from the straight interface towards the center of the semicircular block, as shown here. Mark the normal along the 0,0 line. Measure the incident angle and the corresponding refracted angle. Repeat a few times with different angles of incidence. You can see that when the incident angle increases, the refracted angle also increases. But they are not equal. They are not directly proportional. So how to find the relationship? After all the measurements, find the sine values of all the angles. Fill in the table using a calculator. Lastly, plot a graph of sine angle I against sine angle R. It should be a straight line through the origin. A straight line graph in this case shows that the sine value of the refracted angle is directly proportional to the sine value of the incident angle, and hence, as the Snell's law says that sine angle I over sine angle R equals to a constant, and Snell called it refractive index, eta. When one of the medium is air or vacuum, and the other is medium X, the refractive index of X is the sine angle in air over the sine angle in X. In this way, the refractive index of air is 1, and the refractive index of other media are all larger than 1. A medium with a larger refractive index is said to be optically denser, and it reflects light more. Diamond reflects light a lot, and so the refractive index of diamond is very much larger than that of the other medium. If none of the medium is air, Snell's law appears in a different format, as you may find on page 40. So let me show you how to apply the formula as in question 33a. We may have sine 50 degrees over sine 30 degrees equals the refractive index of x, and it equals 1.532. And what about question 34? Let me show you part C. Now, sine 60 degrees over sine theta equals 2.42. And so, sine theta equals sine 60 over 2.42. That equals 0.357. And thus, theta is at sine 0.357, which is about 21 degrees. From these two questions, we may have the following observations. When light travels from air to another medium, or from one with lower refractive index to another with higher refractive index, then the refracted angle is smaller, and so the light ray bends towards the normal. On the other hand, when light travels from any other medium to air, or from one with higher refractive index to another with a lower one, then the refracted angle is larger, and so the light ray bends away from the normal. There are more challenging questions, which you may find on page 40, in which none of the medium is air, and you will have to apply another format of Snell's law. So, in the coming lesson, you will do an experiment on your own, finish the report, and then do calculations using the Snell's law. As a gentle reminder, remember to show your steps clearly in your exercise book for all the calculations. Now we play the video and copy the notes from the video. That's the end. Thank you.